Hello, welcome to homework 5.05, which is all things slope related. All right, we're taking a step back from graphing inequalities for a day to practice everything that we know about slope. All right, so question 1 says determine the slope of the line that passes through each pair of points. So this is where we're going to use our slope formula, which is m equals y2 minus y1 over x2 minus x1. All right, so the biggest thing with these problems is just making sure that you take your time. It's easy to plug things in the wrong spot if you're trying to rush through these. So just take your time and say, all right, this first point is x1, y1. This second point is x2, y2. Every point needs an x and a y. And then we just plug the points in. So this is going to be negative 2 minus 3 over negative 2 minus a negative 1. Now, when we have minus a negative, that basically just turns into a positive. So in this case, we've got negative 2 minus 3, which is negative 5. Negative 2 plus 1 is negative 1. So negative 5 divided by negative 1 is just a positive 5. All right, and then it's just kind of repeating that for the next three problems. So m equals y2 minus y1 over x2 minus x1, x1, y1, x2, y2. Now, sometimes kids ask, does it matter which one I make x1, y1? Does it matter which one I make x2, y2? It does not. You just can't mix and match. I couldn't say like x1, y2, x2, y1, they have to be consistent. So this is either x2, y2, or it's x1, y1. This is either x2, y2, or x1, y1. You have to keep them together, right? But I usually just kind of do them in order. So on this one, we've got negative 2 minus a negative 8. So minus a negative is going to become positive. And then x2 minus x1 is going to be 7 minus a negative 4. So again, that's also going to turn into a positive. So negative 2 plus 8 is positive 6. 7 plus 4 is 11. Okay, so that would be our slope for number 2. If we look at number 3, all right, again, you're seeing it's just kind of the same thing over and over again. So x2 minus x1. The biggest thing is just memorizing the formula, making sure you have the formula memorized. So there's my x1, there's my y1, there's my x2, there's my y2. So we've got 0 minus 2, negative 3 minus negative 3. All right, so 0 minus 2 is negative 2. Negative 3 minus a negative 3 is really negative 3 plus 3, which is 0. So let's take a look what happens if we actually do negative 2 divided by 0 on our calculator. All right, so if we do negative 2 divided by 0, we get an error divide by 0 message. All right, so a lot of times negative 2 divided by 0, kids want to write 0, but that's not actually true. Negative 2 divided by 0 is what we call in math undefined, all right, because you can't really divide by 0. So when you get one like this, you don't want to leave it as negative 2 over 0. You want to actually write the word undefined. And if it was a multiple choice question, there wouldn't be a negative 2 over 0. There would just be the word undefined as kind of one of the answers. All right, last but not least, number 4 here. So m equals y2 minus y1 over x2 minus x1. So there's our x1, there's our y1, x2, y2. So we have negative 5 minus negative 6, and then negative 2 minus 1. All right. Double negatives here, so that's going to become plus 1. And then we just get negative 5 plus 6 is a positive 1. negative 2 minus 1 is a negative 3. So there we have a slope of negative 1/3. Okay. All right, number 5, also asking for the slope, but instead of giving us points, it's giving a graph. Now there are kind of two ways you can do this. One way is we could just get points. So if I take a look at this point right here, I could say, all right, that's back 1, 2, 3, 4, and up 1, 2, 3, 4. So this point is negative 4, comma 4. And then I could say, all right, this point right here is, I'm not going left or right at all, so that's a 0, and I'm going up 2, so this point is 0, comma 2. And then with both of those points, I could do exactly what I did up above. I could also use this point if I wanted to, which is 4, comma 0. I could just pick any two of these 3 points and use the slope formula. The other way to do it is to remember that slope is rise over run. So if I look at this graph and I go from this point to this point, I can see that my rise is actually going down 2, so that would be a negative 2, and my run is going over 4, so that would be a negative 2 over 4, which reduces to negative 1/2. All right, so there's kind of two ways to do that. You can either use the points and calculate it using the formula, or you can look at the picture, and as long as you remember that it's rise over run. Now, sometimes kids are like, wait, but like, couldn't I have done, up this way and then back this way? Like, how do you know which way to go? And it doesn't actually matter. So if you went to the left, you'd be going up 2, so that would be a positive 2, but you'd be going back 4, which would be a negative 4. Either way, you're going to end up with negative 1/2. So it doesn't matter whether you go down and then over or up and then back, you're still going to end up with the same answer of negative 1/2. And you're also going to end up with the same answer if you just use the slope formula. Like, let's just do the slope formula quick. x1, y1, x2, y2. So if I do 0 minus 2 over 4 minus 0, I'm going to end up with negative 2 over 4, which is going to reduce to negative 1/2. So you can see I just did it 3 different ways, and every way gave me the same answer. Okay. So let's take a look at 6. Find the rate of change. Explain what the rate of change means for this situation. Okay, so rate of change is basically just code for slope. All right, so basically they're just asking for what is the slope in this problem, and you can basically think of this table as a table of values for when you're graphing a line. Time is your x, temperature is your y. Just the same way that it shows up when we graph points. We put the x on the left, we put the y on the right, so there we go. We have our table, x and y, and then these are just different points. So you don't have to use all the points. You just pick the 2 that you want to use. The slope formula needs 2 points, so you pick 2 that you want to use. I'm going to avoid negatives because why introduce that opportunity for a mistake? So I'll get rid of that one. I'll get rid of those because they're bigger, and I'll just use those 2 points. I'm just eliminating, a bunch of them and just saying, all right, these are the 2 I'm going to use. So otherwise, it's exactly like what we were doing before, y2 minus y1 over x2 minus x1. So just pick, okay, this will be my x1 and y1. This will be my x2 and y2. So we've got 16 minus 7 over 7 minus 4. So that's 9 over 3, or just a slope of 3. So if you remember, the y is the temperature, so we're basically saying that the temperature changes 3 degrees every hour. Okay? Because remember, it was 3 degrees per hour. We put the degrees on top and we put the hours on the bottom. Okay, so the temperature changes 3 degrees every hour. All right, let's take a look at the back. Okay, so the back is just kind of some graphing review. It says consider the linear function y equals negative 1/3 x minus 2. Graph this line on the grid using its slope and y-intercept. Okay, so remember the slope is whatever's next to the x. So the slope is negative 1/3. So because it's a negative 1, that means we're going to go down 1 and over 3. All right, the reason we're going to the right 3 is because that's a positive 3. The reason we're going down 1 is because that's a negative 1. And then our y-intercept is negative 2. That's the number that's not next to the x. So if we were graphing this, we would start down 2 because the y-intercept is negative 2. So we're starting at negative 2 on the y-axis. And then we would just go down 1 over 3, down 1 over 3. And you can always do the exact opposite. So we can go up 1, back 3, up 1, back 3. We get our points. We can connect those points. We can throw a label on this, so y equals negative 1/3 x minus 2. And then let's see what the next question asks. All right, none of the following points when plotted would fit on this particular grid, but that doesn't mean they don't lie on the line. It extends forever in both directions. Determine which points lie on the line and which do not. All right, so we've talked about this, that every point on the line is a solution to the equation. So we can just plug these in and see which ones are solutions. All right, so there's my x, there's my y. So if I plug this in, I've got my y equals negative 1/3 x minus 2. All right, the 30 is going to go in for the x, the negative 14 is going to go in for the y. So I've got negative 14 equals negative 1/3 times 30 minus 2. All right, negative 1/3 times 30. If you're not sure what that is, just remember you can do that on your calculator. Parentheses, negative 1 divided by 3 times 30. And we get a negative 10 there. All right, so this is going to be negative 14 equals negative 10 minus 2. Negative 10 minus 2 is negative 12. So this first one does not check out, so this would be a no. All right, let's try the second one. So we're going to do the same thing. Y equals negative 1/3 x minus 2. I'm going to plug in the 8 here. Negative 1/3 times negative 30 minus 2. Now we already did negative 1/3 times positive 30 and got negative 10. Now we're doing negative 1/3 times negative 30, so it's still going to be 10, but the difference is now that we have a negative times a negative, it's going to be a positive 10, and then positive 10 minus 2 is 8. So this one does check out, so this one would be a yes. So let's move on to the last questions here. For each of the following linear equations, rearrange into y equals mx plus b form, and then graph on the grid. All right, so again, this is just kind of review. We're just going to be solving for y, and then graphing our equations. So we've got this first one here, 3y equals x minus 3. We need to solve for y. 3y equals x minus 3. So we got to get rid of this 3 here. So we divide everything by 3. Now the key to remember is on this x here, this is really 1x. So when we divide this, it's 1 divided by 3, or just 1/3 x, minus 3 divided by 3, so that's a -1. And then once you have this, it's your choice on how you graph it. You either put it into your calculator or use the slope and the y-intercept. I'll do this one on the calculator. I'll do the next one using slope and y-intercept. So I just go to my y equals. I type in 1/3 x minus 1. All right, so there's the 1/3 x minus 1. I go to second graph, and then I'm going to get this table of points. And what I want to do is just use the ones that don't have decimals. So -6, -3. Let's see, what do we have next? -3, -2. There's one. 0, -1. There's another one. So -3, -2. 0, -1, and then if you keep scrolling, the next one's going to be 3, 0, and then the one after that is going to be 6, 1. Okay, so you can get a whole bunch of points there. Remember, the minimum that I'm usually looking for is 4, so at least have 4. And then it's just a matter of graphing these points. The x is your left to right, the y is your up and down. So -6, -3 would be back 6, down 3. -3, -2 would be back 3, down 2. 0, -1 would mean I don't go left to right at all. I just go down 1. 3, 0 would mean I go over 3 because that's my x, and then I don't go up and down at all because that's my y. And then 6, 1 would just be over 6 and up 1. So I've got all my points. I'm going to connect them. I'm going to put an arrow there to show that it keeps going, and then I'm going to put on my label 3y equals x minus 3. All right, here's question B. 4y plus 16 equals -2x. So 4y plus 16 equals -2x. So I'm trying to get the y by itself, which means I need to get rid of the 16. And I need to get rid of the 4. So I'm going to start by subtracting 16 from both sides. These will cancel out. I get 4y equals -2x minus 16. Now I need to get rid of the 4. This is 4 times y, so the opposite is to divide by 4. And I end up with y equals -2 divided by 4 would be -0.5, which math fracts to -1/2 x minus 4. So, if we think about this, doing it the slope y-intercept way, our slope is -1/2 because that's the number next to the x. So that means we're going to go down 1, because it's always rise over run, and to the right 2. We're going down 1 because it's a -1. We're going to the right because it's a +2. And then our y-intercept, which is where we start our line, is going to be starting down here at -4, because that's the number not next to the x. So, if I'm doing my graph, I start down 1, 2, 3, 4. And then I'm just going to go down 1, over 2, down 1, over 2. I'm kind of running out of space pretty quick, but remember you can also do the exact opposite. I can go up 1, back 2, up 1, back 2, up 1, back 2. All right, and then I get a nice little line that I can connect. I can throw my label on there. 4y plus 16 equals -2x. And then I am done with homework 5.05. All right, I hope this was of some help. Have a good day.